Ever wondered how a capacitor works? Today, we delve into the fascinating world of electronics to unravel the mystery behind these vital components. Imagine a capacitor as a tiny rechargeable battery within an electronic circuit. However, unlike batteries that store energy chemically, capacitors store energy in an electric field. This feature allows them to quickly charge and discharge, making them essential in many electronic devices. But how exactly does a capacitor accomplish this? The secret lies in its basic structure. A capacitor consists of two conductive plates separated by an insulating material known as a dielectric. When voltage is applied to the plates, an electric field is created across the dielectric. This field causes positive charges to accumulate on one plate and negative charges on the other. The process of charging a capacitor is akin to filling a water tank. The more water you pump into the tank, the higher the water level rises. Similarly, the more charge you pump into a capacitor, the higher the voltage across it. However, this doesn't go on indefinitely. Just as a water tank has a limit to how much water it can hold, a capacitor has a limit to how much charge it can store. This limit is known as the capacitance and is measured in farads. A capacitor with a higher capacitance can store more charge at the same voltage. Now, let's talk about the discharge process. It's as if you've opened a tap at the bottom of the water tank. The water begins to flow out and the water level starts to drop. Similarly, when a path is provided for the charge to flow, the capacitor begins to discharge and the voltage across it decreases. So why are capacitors so crucial in electronics? One of their main roles is in filtering and smoothing out fluctuations in power supply voltages. They can quickly absorb and release charges, thus compensating for any sudden changes in voltage. They also play a crucial role in timing circuits, where the charge and discharge times are used to generate specific time intervals. In a nutshell, a capacitor works by storing energy in an electric field created between two conductive plates, separated by a dielectric. It charges by accumulating positive and negative charges on these plates, and it discharges by releasing these charges when a path is available. The amount of charge a capacitor can store is determined by its capacitance, and this ability to store and quickly release charge makes capacitors indispensable in many electronic devices. Electronics might seem complicated, but when you start to understand the individual components like capacitors, the bigger picture becomes clearer. So next time, when you use any electronic device, remember the humble capacitor, working tirelessly behind the scenes to keep everything running smoothly.